Let's look at the 2022 further exam 2 question 3 in networks. A series of pipelines is installed to allow for the flow of stormwater from the holiday park. The capacity of these pipes in liters per minute is shown in the directed network. So first what I've done is I've indicated all the places where there's going to be an inflow outflow, and that is at L and at N here. And now what I'm going to do is to check out how much water flows through this network, the capacity of the pipes. So if you look at the inflow at L, now even though 20 can flow through this pipe from source to J, it is only 18 that can flow to L. So all for 18 will flow, but only 18 out of 20 will flow and reach here. Now, the only other inlet towards L is at this point here. So maybe I should have indicated an inflow here as well. So now let's look at the water that can flow from S to K. Now the pipe K to L is backwards, so obviously we can't, water can't flow from S to K to L, and therefore it will take the path through from K to O and O to R first. So 20 out of 20 will flow here, 20 out of 35, that leaves you with the remaining 15. And of that 20 that reaches this point, only 19 will flow through. Now the remaining one will find an outlet maybe through here, or through here. Now if it goes through this pipe which has a capacity 8, so 1 will flow through that and reach this point here. Now the remaining 15 that's there will flow through pipe SK and go through pipe KN. So that 15 will flow through here and reach, that will be the other inflow here. So totally that makes 16, of which 15 will continue to flow through that, and the remaining one could flow through that and reach here, but it really doesn't matter because it has no outflow over here. And so of the 15 that flows through pipe NM, it will then flow through ML, but only it has a capacity of 5, so only 5 of that 15 will flow through here and reach this inflow here. The remaining 10 will flow through here. As we can see, it's a capacity of 10, and we see that because this has a capacity 16, it can flow through there as well. Now the question here that they have asked is, I think it's the last question here that creates most of the problems. If the capacity of one pipe is increased, complete the sentences by filling in the boxes provided. The pipe that should have a capacity increase to cause the largest increase in flow from source to sink is the pipe that runs. Now it is from L to R simply because there's an total inflow here of 23. And but it's only 15 that can flow out here. So if I was to increase the flow from source to sink, I should increase the pipe that runs from L to R, and its new capacity should at least be 23. This should be at least 23 in order to accommodate this inflow to increase the total maximum flow from the source to the sink. So that is one question that creates a lot of problems here, but otherwise, let's go through the other questions. Let me first delete all that. I addressed that question, though it was the last one first, because I find most of my students get stuck on that one and manage to actually work their way through the others. So let's look at the first question. Determine the capacity of cut 1. Now, for those of you who don't know how to calculate the capacity of a cut, you include all those pipes which flow from the source to the sink. And so first I usually indicate as to where it cuts on the diagram. So for the cut 1, it cuts here, it cuts there, and there. Now, the ones that are included are this edge, because it is from the source side to the sink side, and this one flows from the sink side into the source side, so it's not included. This edge flows from the sink side to the source side, included. This edge flows from the sink side to the source side, included. This one similarly flows from the sink side to the source side and therefore included. And this one is included on the same basis as well. So when we add all these values, we get 15 plus 15 plus 14 plus 14 plus 11 plus 19. So that is totally 30 there. And we get, so that's 9, 14, 4, 2, 3, 4, and 74. And that is 74. For some of you who get confused between the sink and the source side, all you have to do is, let me delete this. All you have to do is maybe using a color pencil, you could actually sketch one side of the cut and the gray area is actually the sink side and the white area is the source side. So if you were to look at all those arrows that flow from the white area to the gray area, that is this one. This one flows backwards from the gray to the white and therefore do not include it. This one flows from white to the gray area. This one white to gray. That one white to gray, and that one white to gray as well. So you include all those that flow from the white to the gray side, or any other color that you can sketch. You can sketch either side and think of, if I had grayed out the source side, then it should be gray to the white side. So let's now address the other questions. Now the next question is, what is the maximum flow of storm water from the source to the sink? Now there are two ways of doing it. One is to cut this network at along various edges and then find the maximum flow. But I find this method easier. I call it the zero cut method. And the first thing I do is I lay out all the paths. And it's pretty easy. You just have to do it methodically. So I record 15 first along the path SJLR, and then I subtract along that path. I subtract 15 minus 15, 0. 18 take away 15, 3. 20 take away 15, 5. And then I lay out the next path. So that obviously has to be SJL, and then it comes down here. Now remember, once you have created a 0 along any edge, that means the capacity of that pipe has become 0. No water can flow through that, and so you have to take another path. So we are coming down LK, and then it flows to LN, M, Q, and R. And if you look along these paths, the smallest capacity is the 3 over here. And so we record the 3 against that path. And then we subtract the value 3 from all the values on that path. And so we subtract, so 3 take away 3, 0, 5 take away 3, 2, and then we came down LK, so that is 9, and then 19 take away 3 is 16, and then 15 take away 3 is 12, 7, 16 take away 3 is 13. So the next path that we look at is SKN, because all these pipes still have a capacity, MQR. So along this path, as you can see, 7 is the smallest value. And so we record 7 against that path, and we subtract 7 minus 7, 0. That's 13 minus 7 is 6. And minus 7 is 5. And 16 take away 7 is 9. And 35 take away 7 is 28. Now we again try and find another path that could be taken by this flow, and the only one that we have left is, we can't go along this one simply because this is a reverse path, and therefore the only one that we can find is along SKOR. And if you look at all these values along that path, 19 is the smallest value, so we subtract 19 minus 19, 0, 20 minus 19, 1, and 28 minus 19, 9, and record 19. Now the important thing here is that you should make it a point of recording those smallest values that you choose along each one of these paths, because if you forget to do that, then obviously you won't have a value against that path, and could cause you to make mistakes. So these are all the flows that are possible along this network, and when we add them all, we get 44, which is the maximum flow of stormwater from source to sink. We find this the easiest way, and once you've done that, if they ask you to find the cut, then you can go ahead and find the cut that gives you a value of 44 across this network. Now, Joe would like to increase the maximum flow through this network. The maximum flow through this network may be increased by reversing the direction of flow through one pipe or increasing the capacity. So the direction of one pipe that can be increased to increase the flow, the direction of flow is increased through one pipe. Complete the sentence. The pipe that should be reversed to cause the largest increase in flow is Q to P. Here, if we look at, so if we look at Q to P, let me identify Q to P. That is this one. The other one that has a direction opposite to the flow is, let me have a look here, is that one. And so the one that's Q to P is still has a capacity of 12, which would mean that I could have, if the direction of QP was reversed, I could still have, because there's still a capacity of 9 here, 9 here, and that could have flown through this pipe as well. That could have flown through QP as well. And so I could have increased it by 6 because there's still a capacity of 6 to go there. And so the one that I should be reversing is QP. I have explained the last question, which talks about increasing the capacity to cause the largest increase in flow. So hopefully this helps, and yep, see you in another lesson. Bye-bye.